Welcome to our channel. We are dedicated to free thinking. Join us and embrace the power of independent thought. Embark on a liberating voyage where you decide the truth. Sit back and enjoy.
Have you ever wondered what our sun is made of? Well, the answer might surprise you. The sun, in its fiery, radiant glory, is mainly composed of the two lightest elements in the universe, hydrogen and helium. Let's delve a little deeper. The sun's incredible energy stems from a process known as nuclear fusion. In the sun's superhot core, hydrogen atoms under immense pressure collide, forming helium and releasing a tremendous amount of energy. This energy in the form of heat and light is what gives life to our planet, Earth. But wait, there's more to the sun than just hydrogen and helium. Within its blazing inferno, you'll also find traces of other elements. Oxygen, carbon, neon, and even iron. Yes, the same iron you find in your breakfast cereal. It's fascinating to think that the same elements found on Earth are also found in the sun, isn't it? Moving away from the sun, we come across the rocky inner planets, but what exactly are they made of? First up, we have Mercury, the smallest and closest planet to the sun. Don't let its size fool you, though. Mercury is essentially a giant ball of iron enveloped in a thin shell of silicate rock. This little planet's metallic heart makes up about 75% of its diameter, a testament to its iron-rich composition. Next, we find Venus, often considered Earth's sister planet due to their similar size, mass, and density. However, the resemblance ends there. Venus boasts a thick, toxic atmosphere primarily composed of carbon dioxide with clouds of sulfuric acid. But here's a fascinating fact. Billions of years ago, Venus may have been quite like Earth, with mild temperatures and vast oceans. However, a runaway greenhouse effect transformed it into the inhospitable world we know today. Then, there's our home, Earth, the only known planet to support life. It's a beautiful mix of elements with an iron core, a mantle rich in magnesium and silicon, and a crust mostly made of oxygen and silicon. Throw in some nitrogen and oxygen for the atmosphere and a dash of liquid water, and you've got the recipe for life. Finally, we reach Mars, our red neighbor. Mars earns its nickname from its iron-rich soil, which gives the planet its distinctive reddish hue. Beneath its rusty exterior, Mars is primarily composed of rock and metal, much like Mercury. But unlike Mercury, Mars also has a thin atmosphere, mainly made up of carbon dioxide, with traces of nitrogen and argon. From the metallic Mercury to the enigmatic Venus, from our life-sustaining Earth to the iron-rich Mars, these inner planets truly are a diverse bunch. Each one is a testament to the variety and complexity of celestial bodies, displaying unique compositions that contribute to their physical characteristics and potential to support life. From iron-rich Mars to our life-sustaining Earth, these inner planets truly are a diverse bunch. Beyond the asteroid belt lie the gas giants. But don't let their name fool you, they're not made entirely of gas. Jupiter and Saturn, the two largest planets in our solar system, are often referred to as gas giants. But this is a bit of a misnomer. Yes, they are cloaked in thick atmospheres of hydrogen and helium, but beneath these gaseous layers things get a bit more solid. Let's start with Jupiter, the giant of giants. It's so big that over 1,000 Earths could fit inside it. But what's it made of, you ask? Well, beneath its swirling, stormy atmosphere, there's a sea of metallic hydrogen, a substance that's created under extreme pressure, which we don't find anywhere on Earth. Deep down, at Jupiter's core, things get even more interesting. There's a solid core, potentially made up of heavy elements like rock and metal, though scientists are still figuring that one out. And then there's Saturn, the ringed beauty. Much like Jupiter, Saturn boasts an atmosphere of hydrogen and helium. Beneath its golden clouds, there's a layer of metallic hydrogen, and deeper still, a rocky core. But Saturn's standout feature is, of course, its dazzling ring system, made up of countless particles of ice, dust, and rock. But that's not all. These gas giants are also home to a multitude of moons, each with its own unique characteristics. Jupiter, for instance, has a staggering 79 moons, including Ganymede, the largest moon in the solar system. Saturn is a whopping 82 moons. These gas giants, with their multitude of moons and complex compositions, add a sense of wonder to our solar system. They remind us that there's so much more to discover and understand about the universe we inhabit. Just imagine what secrets might be hiding beneath those thick, gaseous atmospheres. But for now, let's move on to the next chapter in our cosmic journey. Further still from the sun, we find the ice giants, but what sets them apart from the gas giants? Quite a lot, as it turns out. The ice giants, Uranus and Neptune, are the 7th and 8th planets from the sun. They are called ice giants, not because they are made of ice in the way we understand it, but due to the high proportion of ices in their makeup. These ices are in fact substances like water, ammonia, and methane, which are present in substantial quantities. Unlike the gas giants, Jupiter and Saturn, which are primarily composed of hydrogen and helium, the ice giants have a much higher proportion of these heavier volatile substances, hence their name. However, don't let the term ice mislead you. These substances are not necessarily in a solid state. Depending on the temperature and pressure, they can exist as gas, liquid, or even a high-pressure form of ice. Let's delve a tad deeper into these mysterious planets. Uranus, the azure beauty of our solar system, has a thick, icy atmosphere that gives it its distinctive bluish-green color. This color is due to the methane in its atmosphere, which absorbs red light, allowing only the blue and green wavelengths to be reflected back into space. Neptune, the furthest planet from the sun, is a deep, vibrant blue. Like Uranus, its color is a result of the methane in its atmosphere. However, Neptune is a more intense blue, suggesting it may have an unknown component that gives it an extra color boost. The ice giants are also unique in their magnetic fields. Unlike the Earth or the gas giants, where the magnetic fields are aligned with the planet's rotation, the magnetic fields of both Uranus and Neptune are significantly tilted. This suggests that the internal structures of these planets are quite different from those of the other planets in our solar system. These distant icy planets remind us of the incredible variety and vastness of our solar system. They provide us with a deeper understanding of the diverse celestial bodies that coexist in this vast cosmic neighborhood we call home. Finally, we reach the outskirts of our solar system where the dwarf planet Pluto resides. But could life exist so far from the sun? We know Pluto as a distant, icy world, a dwarf planet that orbits the sun in a region known as the Kuiper Belt. It's a small, frigid body with a heart-shaped glacier that's caught the world's eye. This glacier, known as Sputnik Planitia, is made up of nitrogen, methane, and carbon monoxide ices. Its surface, a frozen landscape, reaches temperatures as low as -375 degrees Fahrenheit. But there's more to Pluto than just its icy exterior. Beneath the surface, there's a possibility of a subsurface ocean of slushy water ice. This hints at a complex internal structure, one that could potentially harbor life as we know it. Pluto's planetary status has been a subject of debate since its reclassification as a dwarf planet in 2006. While it's no longer officially recognized as the 9th planet in our solar system, Pluto continues to captivate scientists and space enthusiasts alike with its unique characteristics and potential for discovery. The possibility of life on Pluto is a tantalizing topic. While the surface conditions might seem inhospitable, life as we know it has proven to be incredibly resilient and versatile. From microbes that thrive in the scorching heat of deep-sea vents, to organisms that survive in the freezing conditions of Antarctica, life has shown us that it can exist in the most extreme conditions. Similarly, if there's a subsurface ocean on Pluto, it could possibly be a habitat for life. Though it's a long shot, it's a possibility that continues to captivate scientists and spark our imaginations. The same goes for other celestial bodies in our solar system. From the icy moons of Jupiter and Saturn to the dwarf planet Ceres, the possibility of life beyond Earth continues to be an exciting field of study. Whether or not life exists elsewhere in our solar system, there's no denying the incredible diversity and complexity of the celestial bodies that orbit our sun.
Thanks for watching. Please subscribe. Thank you.